China's Chang'e lunar missions have truly transformed our understanding of the Moon, offering a fresh perspective on our closest celestial neighbor. These missions have not only advanced China's space program, but have also pushed the boundaries of what humanity knows about the lunar surface. For decades, NASA's Apollo missions gave us our first close-up view of the Moon, capturing the world's imagination and providing invaluable data. Those early missions were groundbreaking, but they were just the beginning. Today, new technology brings sharper eyes, more precise instruments, and a flood of new questions. Satellites and telescopes now reveal details that were once invisible, opening up mysteries we never knew existed. The Chang'e program, named after the legendary moon goddess, has landed advanced robots, sent orbiters to map the surface, and even brought back precious lunar soil samples to Earth for study. Each mission builds on the last, revealing more secrets. The Chang'e missions have a clear and ambitious goal: to study the Moon's surface, its composition, and its ancient history. They're searching for clues about how the Moon formed and evolved over billions of years. China's scientists want to know what the Moon is made of, whether it holds valuable resources like water or rare minerals, and what hidden dangers might threaten future explorers. Every sample and measurement brings us closer to answers. Their discoveries are reshaping the world's plans for exploring, and maybe even living on, the Moon someday. International collaboration and competition are both heating up as new findings come to light. This essay explores what China's missions have found so far. Some discoveries have surprised everyone, challenging old assumptions. Others are more troubling, raising new concerns about lunar hazards. The Moon is not a friendly place. Its surface is harsh, battered by meteorites, and covered in fine, dangerous dust. It's more hostile than we ever imagined, with extreme temperatures, treacherous terrain, and constant radiation from space. Let's dive deeper into the dark truths hiding just beneath the Moon's pale surface, and uncover what these new missions are revealing about our mysterious neighbor. The question remains: are we truly ready to face the Moon's secrets and the challenges that come with them? From afar, the Moon looks smooth and peaceful. Up close, it is nothing like that. The surface is covered with rocks, craters, and a layer called regolith. This regolith is a powdery mix of dust, crushed rocks, and tiny glass beads. It is not like dirt on Earth. For astronauts and robots, this is a dangerous place. The ground is uneven and sometimes slippery. Footprints last forever. Machines can get stuck or damaged. Even small movements can kick up clouds of dust. The Chang'e landers and rovers sent back thousands of images. They showed a surface that is raw, rough, and filled with hidden threats. The wheels of the U-2 rovers sometimes skidded or jammed. The regolith's fine grains found their way into every crack. This landscape isn't just a backdrop for adventure. It's a real challenge for anyone hoping to explore the Moon, or make it their new home. One of the most surprising findings from China's recent lunar missions is the true nature and texture of lunar soil, something that has fascinated scientists for decades. When we imagine the Moon, we might picture a smooth, dusty surface, but the reality is far more complex and challenging. The dust that covers the Moon is not soft or smooth, like the sand we find on Earth. Instead, it is gritty, abrasive, and extremely rough to the touch. Under a microscope, lunar soil reveals its true character. It is sharp, jagged, and potentially dangerous to both humans and machines. Many of these tiny grains are shaped like minuscule shards of glass, with edges so fine and pointed that they can easily slice through materials. This remarkable sharpness is a direct result of the Moon's violent history, marked by countless meteorite impacts over billions of years. Unlike Earth, the Moon has no air or water to gradually wear down and smooth the rocks. There is no wind or rain to erode the sharp edges. Instead, meteor impacts constantly shatter the surface, breaking rocks into countless sharp fragments and scattering them across the barren landscape. Over millions of years, these fragments pile up, forming deep layers of regolith that become even more compacted and razor-like with time. China's Chang'e landers have carefully collected and analyzed these soil samples, confirming just how harsh and abrasive the lunar surface truly is. For astronauts, this sharp lunar dust is a serious hazard. It can quickly wear down gloves, scratch visors, and damage the outer layers of spacesuits. The dust can even cut through protective gear, clog machinery, and grind down moving parts on rovers and other equipment, making long-term lunar missions especially challenging. Even inside a spacecraft, lunar dust can float in the air, infiltrating cabins and causing technical problems or health risks for the crew. Apollo astronauts experienced these dangers firsthand, reporting headaches, moon hay fever, and even lung problems after breathing in the fine, abrasive dust. China's robotic missions have shown that this problem remains just as real and pressing today, as lunar dust continues to pose a threat to exploration. Anyone hoping to work or live on the moon in the future will need to develop new technologies and strategies to protect themselves and their equipment from this silent, sharp, and ever-present threat. Lunar dust isn't just sharp, it's sticky in a way that Earth's dust isn't. Unlike the dust we find at home, which can often be brushed away, lunar dust seems to have a mind of its own, stubbornly attaching itself to anything it touches. This is because lunar soil grains are statically charged. Each tiny particle acts like a miniature magnet, clinging to surfaces with surprising strength. With no air or moisture to drain away the charge, the dust clings to everything it touches. The moon's lack of atmosphere means there's nothing to neutralize this static electricity, so the dust just keeps building up. This was a big problem for the Chang'e rovers and landers. Every mission to the moon has had to contend with this relentless, ever-present dust. Dust stuck to solar panels, cameras, and joints. It coated delicate instruments, reducing their effectiveness and making routine operations much more difficult. It built up on wheels and inside gears. Over time, this buildup can cause mechanical failures, grinding down moving parts and making repairs nearly impossible in the harsh lunar environment. China's scientists saw how hard it was to keep equipment running. They spent countless hours analyzing dust-covered machinery, searching for ways to protect future missions. The problem? Dust blocks sunlight from reaching solar panels, making batteries run out faster. Even a thin layer can dramatically reduce the power available to rovers and landers, cutting missions short. It can jam moving parts or scratch lenses. Sensitive equipment becomes unreliable, and valuable scientific data can be lost if cameras or sensors are damaged. For humans, the danger is even greater. Lunar dust is so fine and abrasive that it can wear down spacesuit fabric, threatening the safety of astronauts. Dust can cling to spacesuits and be carried inside habitats. Once inside, it's almost impossible to remove completely, and it can contaminate living spaces and equipment. Once there, it floats in the air and can get into lungs or eyes. Inhaling or touching this dust could cause serious health problems for anyone living or working on the moon. Even NASA didn't realize how big this problem was at first. Apollo astronauts reported how the dust got everywhere, causing headaches for engineers back on Earth. The Chang'e missions showed it's a long-term challenge for moon explorers. Dust isn't just a nuisance, it's a threat to every aspect of lunar exploration, from technology to human health. Solving the dust problem will be key if people ever hope to work or live safely on the moon. Future missions will need new technologies and strategies to keep this hidden menace at bay, ensuring that lunar exploration can continue for generations to come. For years, people thought the moon was dry and lifeless, but China's Chang'e 5 mission made a stunning discovery: traces of water inside moon rocks. This water isn't liquid, but molecules trapped in minerals. Scientists got really excited. Water is vital for life, fuel, and making air to breathe. But getting this water out is hard. It's locked inside the crystal structure of the minerals. You need heat and energy to release it. Plus, there's not much water, just a few hundred parts per million in some samples. China's findings showed that while water is present, it isn't easy to use. Future explorers will need advanced technology to extract it. It might take tons of rock to get just a small amount of water. Water on the moon is precious, but not a simple solution for survival. Another big surprise from China's lunar missions was evidence of recent volcanic activity. Before, scientists thought the moon's volcanoes had been dead for billions of years. But samples from the Chang'e 5 site told a different story. Some rocks are much younger than expected, maybe only 2 billion years old. This means volcanoes were active more recently than anyone thought. China's instruments found signs of cooled lava flows and volcanic glass. This discovery changes our view of the moon's history. It means the moon stayed active inside for a long time. There could be places where underground heat or gases still make the surface unstable. For future explorers, this raises new questions. What other surprises are hidden beneath the surface? Radiation is one of the biggest dangers on the moon. There is no thick atmosphere or magnetic field to protect against space radiation. China's Chang'e missions measured the amount of radiation on the surface. The results were disturbing. Radiation levels are 2 to 3 times higher than on the International Space Station. Long exposure could damage cells, increase cancer risk, or cause acute sickness. Spacesuits and habitats would need heavy shielding to keep people safe. Robots and equipment also suffer. Electronics can break down faster in high radiation. Batteries lose power. Solar cells wear out. All this means the cost and weight of missions go up. If we want to stay long-term on the moon, radiation is a problem we can't ignore. For many years, people dreamed of building bases on the moon. The hope was to mine resources, do science, and someday even live there. But China's discoveries have changed the picture. Sharp, sticky dust makes every step dangerous. Water is hard to get. Radiation is a silent, deadly threat. Even the ground beneath our feet can hide surprises from ancient volcanoes. Every new fact means more challenges for engineers and explorers. China's Chang'e program has shown that the moon is not an easy place. It isn't just a gray rock waiting for humans. It's a world full of hidden dangers and hard problems. Every plan for living on the moon must now face these tough new facts. Given what we know now, are we really ready to live on the moon? It's a tough question. China's Chang'e missions revealed a world far more hostile than anyone expected. Dust can cut and choke. Radiation never stops. Water is locked away and hard to reach. The ground is rough and possibly unstable. Humans are clever and technology is always improving. But these challenges are real. They are not just technical problems. They are fundamental obstacles to surviving and thriving on the moon. Before we rush to send people to live there, we need to ask, are we prepared for the risks? Can we invent the solutions? The moon's dark truths are now clear. Only time will tell if we are ready to face them. The next giant leap may be harder than we ever imagined. China's Chang'e missions were never just about exploration. They're about innovation. From ultra-durable landers to advanced lunar rovers, China's engineers have pushed the boundaries of what's possible in space technology. Their robotic arms scoop up lunar soil with precision. Their spectrometers analyze minerals in real time. Even their communication systems, relaying data across nearly 400,000 kilometers, are a technological marvel. But the impact goes far beyond China's borders. Each breakthrough raises the bar for the entire world. The Chang'e missions have sparked a new wave of international competition and collaboration. Countries and private companies are racing to develop better landers, safer habitats, and smarter robots. The lessons learned from China's lunar tech are shaping global strategies for future missions, not just to the moon, but to Mars and beyond. As China demonstrates what's possible, the world is watching and responding. The new space race is here, fueled by ambition, innovation, and the dream of reaching farther than ever before. The moon is no longer just a destination. It's a proving ground for the future of humanity in space. As China's Chang'e missions continue to reveal the moon's hidden secrets, the world is taking notice and taking action. Leading space agencies, from NASA to ESA to Roscosmos, have issued statements acknowledging the significance of China's discoveries. Scientists worldwide pore over the newly shared lunar data, eager to compare findings and refine their own theories about the moon's origins and potential. Some nations view China's achievements as a call to collaborate, not compete. International partnerships are forming, with researchers exchanging knowledge and even negotiating joint missions. Meanwhile, others see the Chang'e program as a challenge, accelerating their own lunar ambitions to ensure they're not left behind in this new era of exploration. Beyond governments, private companies are energized by the possibilities. Startups and established aerospace giants alike are racing to develop technologies for lunar mining, habitat construction, and deep space travel. often inspired directly by the breakthroughs coming out of China's missions. Yet, amid the excitement, there are also questions. Who will set the rules for lunar exploration? How will discoveries be shared or protected? And as more players join the race, will the moon become a place of cooperation or competition? One thing is clear. China's lunar leap has set off ripples that are reshaping the global space community. The next steps on the moon will not be taken alone. They will be watched, debated, and perhaps even shared by the entire world. Despite the flood of new data and dazzling discoveries from China's Chang'e missions, the moon remains a place of profound mystery. Scientists now have more detailed maps of its surface, richer samples of its soil, and deeper insights into its volcanic history. But many of the moon's secrets still elude us. What lies beneath the ancient craters that pockmark its face? Are there hidden water reserves trapped deep below the regolith, waiting to be found? The origin of the moon itself continues to puzzle researchers. Was it born from a colossal collision with Earth, or did it form elsewhere and later become our companion? Even more tantalizing are questions about the moon's interior. Does it conceal a molten core, or is it long since frozen? And what unknown minerals or resources are yet to be discovered, locked away in shadowed craters or lunar lava tubes? Each new revelation from recent missions seems to open more doors than it closes, hinting at a complex history that we are only beginning to piece together. As scientists worldwide race to decode the moon's story, one truth stands out. For all our technological triumphs, the moon's greatest mysteries still wait in silence, challenging the next generation of explorers to uncover them. As we stand at the edge of a new lunar era, the future of moon exploration promises to be even more extraordinary. The questions left unanswered by China's Chang'e missions have ignited a global spark. Nations and private companies alike are now setting their sights on the lunar surface. Upcoming missions from the United States, Europe, India, and Japan are already in the works, each bringing unique technologies and scientific goals to the table. But perhaps the most exciting prospect is the possibility of true international collaboration. Imagine a future where lunar bases are built not by one country, but through the combined ingenuity of many, where scientists from around the world share discoveries, resources, and dreams under the same alien sky. Plans for joint missions, shared research stations, and even multinational lunar mining ventures are already being discussed. Private companies, too, are entering the race, developing reusable rockets, advanced rovers, and even concepts for sustainable lunar habitats. The moon is quickly becoming a proving ground for the next wave of space innovation, with breakthroughs in energy, robotics, and life support systems that could one day help us reach even farther, perhaps to Mars and beyond. Yet, as we look forward, the spirit of cooperation will be just as vital as technological progress. The moon, once seen as a prize in a race for dominance, is now emerging as a place where humanity might unite, learn, and thrive together. The future of lunar exploration is not just about answering scientific questions. It's about building a shared legacy beyond Earth, one mission, one discovery, and one partnership at a time. What could be the next big breakthrough in moon research? As humanity's ambitions grow, scientists and engineers are turning their attention to the moon's untapped secrets, searching for discoveries that could transform not just lunar exploration, but life on Earth itself. One tantalizing possibility lies deep beneath the lunar surface, vast reserves of water ice hidden in shadowed craters at the moon's poles. Unlocking these frozen treasures could provide not only drinking water for future astronauts, but also the raw material for rocket fuel, hydrogen, and oxygen, enabling sustainable missions deeper into the solar system. Imagine a future where lunar water becomes the lifeblood of space travel, fueling journeys to Mars and beyond. But the moon may hold even greater surprises. Some researchers believe that rare elements in its soil, like helium-3, could one day revolutionize clean energy on Earth if we can master the technology to harness it for fusion power. Others are focused on the moon's unique environment, perfect for building giant observatories that could peer deeper into the universe than ever before, free from Earth's atmosphere. Perhaps the most profound breakthrough will be something we can't yet imagine, a discovery that rewrites our understanding of the solar system or even life itself. As new missions prepare to drill deeper, scan wider, and stay longer, the stage is set for the moon's next secret to be revealed. The next big leap in moon research isn't just about finding resources or planting flags. It's about opening doors to possibilities that could reshape our world and our place in the cosmos. The greatest lunar discovery may still be waiting, just beneath the surface, ready for the next daring explorers to uncover.